In this video, which belongs to again chapter number 1, number systems, we are going to answer an important question, which is what are irrational numbers? So till now we have seen four set of numbers: natural numbers, whole numbers, integers, and rational numbers. Now there is a fifth set of number which is called irrational numbers. So we'll try to understand why irrational numbers exist, why we have to define them, how they are defined, how they are represented, and where do they exist on the number line. So these are the things that we'll see in this video. Now first let's quickly start with our basic natural number. So I'm going to zoom in a bit. Yes. So we have natural numbers as our very starting point of all the numbers. And the way we represent natural numbers is once again this number line. Okay. Uh, yes. And it starts from 1. Okay. And then we have 2. And then we have 3. And so on and so forth. So this arrow is very important. This arrow indicates that the numbers exist infinitely. So once we start from 1, 2, 3, and then there are infinite numbers to the right hand side. So this is how we define our set of natural numbers. Now immediately next to that we have whole numbers. Okay, so let me write it down. Whole numbers, and whole numbers also can be represented on the number line, and this is how we do it. Okay, so here in whole numbers it starts from 0. That's the only difference. Instead of starting from 1, we start from 0, and then the rest is exactly same as the natural numbers: 2, 3, and so on and so forth. So once again this arrow is very important. It indicates that there are infinite numbers on the left hand side. Okay, now if I want to represent these natural numbers and whole numbers in terms of a box, how am I going to do it? So first of all, I'm going to, let's zoom in a bit. I'm going to write here natural numbers. Okay, yes, so these are my, okay, this is my box of natural numbers, and I'm going to make a box around it. So this is my box of natural numbers. Okay, now if you come to whole, now I want to represent whole numbers also using one box. Okay, now the important question is, will the box of whole number be bigger than this natural number box, or it will be smaller than the natural number box? Very obviously it's going to be bigger than this natural number box, because we have added one extra number which is called as 0. If you ignore 0, then it's the same natural number list. So the whole number box that I'm going to draw has to be bigger than this natural number box. Also, another important point, the entire set of natural numbers should exist inside this box of whole numbers. Okay, so first of all, let me, okay, let me quickly make a box of whole numbers. So this is my bigger box of whole numbers. Okay, and let me write down whole numbers. Let's like zoom in. Okay, so these are my whole numbers. Okay, this is my box of whole numbers. Now very important point is, these all set of natural numbers 1, 2, 3, and so on exist as also a set of whole numbers, which means this box of natural numbers should be inside the box of whole numbers. Okay, because these natural numbers consist of all the numbers that the whole numbers consist. So whole numbers is a big box and the natural number is going to be a small box. So what I'm going to do is I'm going to just create a copy of this box. Okay, copy, and I'm going to paste inside this, paste, and I'm going to just put it like this, done. Okay, so this boxing is very important. Natural number box, this box of natural number, it will be inside the box of whole numbers, and this is the concept that we are going to keep on developing when we are going to define more and more numbers going forward in this video. Now the next set of numbers that we want to come across is obviously integers. Okay, so let me write it down here. The next one are integers. So this is my set of numbers called as integers, and again I'm going to draw a number line for integers. The number line of integers is a little bit big. Okay, and importantly it extends on both the sides of the number line, even on the left hand side and even on the right hand side. Okay, so at the center we have 0, then here we have 1, here we have 2, here we have 3, so on and so forth. And on the left hand side we have -1, here we have -2, here we have -3, and so on and so forth. So we can clearly see here in this number line of integers, we have natural numbers 1, 2, 3. We have these whole numbers 0, 1, 2, 3, dot, dot, dot. And at the same time, we have these negative numbers -1, -2, -3. So once again, if I want to do a box representation of these number lines, so this box of this box of integers is going to be the bigger box, and inside that big box, I'm going to put these two boxes, okay, because they are subset of this whole big set, okay. So let me draw. So again, let me like zoom in and let me draw a huge box for my. Oops, I have to enable this. Let me draw a huge box for integers to store integers. This is my box and I'm going to label it as integers. So here it is. Okay. So this is my box of integers. And now inside this box of integers, both these boxes, whole numbers and natural numbers will sit inside. Okay. So let me just create a copy of this. Copy, and I'm going to just paste. So this is how it is. Cool. So this becomes our boxed. This is how we are representing our boxes of natural numbers, then whole numbers, and now even integers. Now going forward, let's take our next list of numbers, which is nothing but, let me use a different color, which is nothing but rational numbers. So here I have my another set of numbers which are called rational numbers. Now rational numbers do not have any representation on the number line, but why we are defining natural numbers is because if you look at this number line, we have 0 and then we have 1, but what about the numbers that exist between 0 and 1? For example, here there is a number called as 1 by 2, which is actually 0.5. Okay, so 0.5 exists between 0 and 1. However, this number 0.5 is not represented in this set of integers. This number 0.5 is not represented in this set of integers. So since this one number is not represented on the number line, on this number line of integers, hence we have to define another set and another box which will define such numbers of the form p by q, and there are many such numbers. Okay, if you zoom in, there's a number 1 by, okay, so there's a number here, there's a number here, there's a rational number here. There are so many rational numbers in between these integers which this set of integers does not include. Hence we have to define a bigger set. Hence we have to define this bigger set which will include these numbers of the form p by q. Okay, so rational numbers are numbers which are of the form p by q, and we all know that p is basically any integer. Okay, and now q is also any integer. Q is also any integer except 0. Q is also any integer except 0. So these are our rational numbers. Now interestingly, all the integers can also be expressed as rational numbers. So thus, when we go into the box representation, our box of rational number is going to be the biggest. So I'm going to draw that big box first. So here we go. Yes, this is my big box of rational numbers, and I'm going to call it rational numbers. Let me just note down. So this is my box of rational numbers. Okay, and once again, if we look carefully, okay, all these integers will be inside this box of rational numbers. Okay, so let me again just copy paste this. Let me cut it out. Okay, copy and paste. Yes, perfect. So this becomes an important boxed representation of all our numbers that we know so far. Starting from a small box of natural numbers, then we create a big box because 0 was not there. Then we created one more big box because negative numbers were not represented. And then we realize, oh, there are more numbers which are of the form p by q, which integers do not contain. So we created another big box, and thus now we have rational numbers. Now, an important question that we have to ask is, do rational numbers represent all the numbers that are existing on the number line? yes or no. So let me note it down here. So this is an important question that we all have to answer. What is that question? Do rational numbers represent all the numbers present on the number line? Does rational number represent all the numbers on the number line? So on an intuitive note, you might think that yes, the rational number represent now all the numbers on the number line. There is nothing else remaining that rational numbers, that this big box of rational numbers does not represent. However, the answer is incorrect, because we have certain numbers of the form I will write now. Let's consider a number p equal to 1.1216389523815 dot. So this number p, it has infinite number of decimal numbers. It has infinite number of decimal digits after this decimal point. And such number is not represented by our rational number definition p by q, because this number, which has infinite number of decimal digits, cannot be represented in the form of p by q. If there were finite decimal digits, for example, let's take another number q, which is equal to 1.1216389. That's it. If there are finite number of decimal digits, then this can be easily represented as 1216389, the whole divided by 1 2 3 4 5 6 7. Okay, so thus this number q can be represented in the form of p by q. Why is that so? Because the number of decimal digits after this decimal point are finite, they are fixed. However, in this number p, after the decimal digits there are infinite numbers, there are infinite digits, and such numbers cannot be represented in form of rational number, which is p by q. Which means which means if you think about this question, do rational number represent all? Do they represent all the numbers present on the number line? No. The answer is no. Let me just write it down. The answer is no. Okay. And thus, the numbers which are not rational numbers, like this number p, okay, okay, like this number p, the numbers that are not rational numbers, the numbers that are not rational numbers are called as irrational numbers, are called as irrational numbers. irrational Irrational numbers. Okay, and that is exactly the topic of this video, that what are irrational numbers. So irrational numbers are the numbers that are not rational numbers on the number line. Okay, they cannot be represented on the number line in the form of p by q. Now, we have defined what are irrational numbers and we know how they look like. Basically, irrational numbers are decimal numbers with infinite number of decimal digits. Now, the important question is, how do we represent them in this box? In this box, the representation, where do irrational numbers fit? So definitely they will not come inside any of these boxes, because the very definition of irrational number are the numbers which are not rational numbers, which means we have to create some another box besides this rational number box. So I'm going to do that. Let me cut it out. Let me create a copy of this box. Copy, and then let's go down here. Okay, we are short of space, and I'm going to just paste it here. Okay, so these are my all the numbers that I have defined so far, and now I have to define one more box here, another box. So I'm going to do that. Okay, and this will be my box of irrational numbers. So irrational numbers. Okay, and thus in our number line there are these two rational numbers and irrational numbers. These two together make the entire number line. So in fact, I'm going to write here plus plus. Okay, so rational numbers plus irrational numbers are all together called as real numbers. And real numbers are the numbers, basically real numbers are the numbers, let me write it down here, numbers present on number line. All the numbers that are all possible numbers that are present on the number line are called as real numbers. Once again, all the numbers that are present on the number line are called as real numbers. Now that real number either could be an irrational number or it could be a rational number. That's a different scenario. Okay, but together rational numbers and irrational numbers together make real numbers, that is all. Okay, the word all is actually very important. All the numbers present on number line. So when we draw a number line, which we have drew 100 times so far, when we draw any number line and you take this as 0 and you take this as 1 and you take this as 2 and you take this as minus 1 and take this as minus 2, so on this number line you take any point. Okay, you take any point. That point is either, okay, that point is either a rational number or it is an irrational number. Okay, either of them. There's only two possibility, either it's a rational number or an irrational number. Same goes with this point. Any damn point on this whole number line will either be a rational number or it will be an irrational number. And thus with this we understand the concept of irrational numbers, why we need to define irrational numbers, why do they exist, and how irrational numbers together with rational numbers combine make up the whole number line that exists, and they are in general called as real numbers.